Hello Longhorns, here is the Algebra 2 Pre-AP review for test 6.1. I'm only going to be working a few of the problems on this review for this video, so I encourage you to work all of the problems on the review to prepare for the test on Thursday. The first problem I'm going to do is problem number 1. And in problem number 1, we need to identify the vertex, the focus, the axis of symmetry, and the directrix. I'm also going to look for the value of P, which is going to help me find the focus and the directrix. So first of all, I would like to find the vertex, and then we will work from there. Alright, so the first thing I did was find the vertex, and as you can see, the vertex, it comes from this value inside the parentheses. This is K, and this value outside the parentheses, which is H. Because our equation is x equals, we have a parabola that's opening left or right. And since this A value is positive, we have a parabola that's opening to the right, or in the positive direction. So I drew a sketch of this parabola with its vertex at -3, 1. -3, 1 is our vertex, h being -3, k being +1. And then I opened it to the positive direction. I also found the value of P. P equals 1 over 4a, and since a is 2, 1 over 4 times 2 is 1 over 8. So I know the value for P is 1 over 8. That means that my directrix and my focus are both going to be 1/8 units away from my vertex. And since my value for y is 1, my axis of symmetry is going to be y equals 1. So I probably want to go ahead and write that down. Okay, axis of symmetry is y equals 1. Now notice how I wrote that as an equation, because the axis of symmetry is an equation. It's either going to be a y equals and a number or x equals and a number. If you forget to write it as an equation, you may lose points on the test. Actually, I know you will lose points on the test. So please make sure that you write your axis of symmetry as an equation, not just a number. Okay, so we know our axis of symmetry. Now we know that that is right here at y equals 1. And we know that our directrix and our focus also lie on the axis of symmetry 1/8 units away from the vertex value for x. So if I look at my vertex value for x, it's -3. So I need to add and subtract 1/8 from -3 to get my values for my focus and my directrix. Alright, so I've found the focus by adding 1/8 to -3, and that gives me a -23 over 8, and I leave this as a fraction with the denominator of 8. So my focal point, or my focus, is going to be -2/3, or -23 over 8, comma 1, because my value for y is 1. And then the directrix is going to be -3 minus 1/8, and that gives me a -25 over 8. So if you're wondering how I got this, I just multiply 3 times 8 and add 1, or subtract 1 in this case. So 8 times 3 is -24 minus 1 is -25. And I went ahead and leave it as a fraction over 8. So this is how we would write the directrix. Now make sure this is a line. Then remember, the directrix is this line right here. Since it's a vertical line, it's going to be x equals -25 over 8. So make sure you're writing your directrix as a line. The focus is a point. It's a focal point right here. This is your focus. And so that's going to be at -23 over 8, comma 1. And that is all the information we need. We got our vertex, we got our focus, we got our axis of symmetry, and our directrix, and we sketched the graph. So the questions on your test could be any one of these parts, or you could have multiple questions on the test that cover these parts. So you need to know how to find each part of the parabola. All right, we're going to do the same thing with question 2. And I'm going to find the vertex first. I'm going to draw a sketch of my parabola, and then I'm going to find the other parts. Okay, so for starters, we found the vertex, and then I went ahead and graphed a sketch of the parabola, and I'll show you how I found the focus and the directrix. So first of all, we have the vertex located at -3, 1. So this is my H, and this is my K. So notice that this time I have a parabola that opens up or down. So that means that this value inside here is going to be the H value because it goes with X, and this value is going to be the K value, and it goes with Y. All right, so my vertex is -3, 1. It's the same vertex we had before, okay? -3, 1, it's right here, okay? But the parabola opens downward. See this negative sign? That means that the parabola opens down, and it's a wider parabola because of this 1/4. This is a compression. So our parabola opens downward and it's compressed. So now what I'm going to do is find the value for P, so I can find the values for the focus that's inside the parabola and the directrix, the line outside the parabola. Okay, so I've done the calculation of P equals 1/4A, and I found that my A value is -1/4. So in order to solve that, I just multiply by the reciprocal of that fraction, and I get 1/4 times -4/1, which just gives me a -1. So my P value is -1. In other words, I'm going to be going in the focus direction, I'm going to be going down 1 unit. So I'm 1 unit away from my vertex. So if I'm at the value -3 for X and 1, or -3 for X and 1 for Y, I'm going to have to take my Y value and subtract 1. So to find the focus, I take my Y value of my vertex, which in this case is 1, and I'm going to subtract 1. Subtract 1. And that's going to give me 0. So my focus is going to be at -3, 0. So my focus is at -3, 0. The directrix is going to be in the opposite direction of that. So I take my value for my vertex, which was 1, and this time I add 1. And that gives me 2. So my equation for my directrix is going to be y equals 2. So you have to make sure you know what direction you're going. So this is my directrix, the blue line, and my axis of symmetry is the x equals line. So let's write our axis of symmetry. The axis of symmetry is the line for the value for x at my vertex. So x equals -3 is my axis of symmetry. And that's it. We've got our vertex, we got our focus, our directrix, and our axis of symmetry. The next problem we're going to do is problem number 5, and this one is use the information provided to write the standard form equation of each parabola. So the standard form equation for parabolas is going to be y equals ax squared plus bx plus c. So you need to remember that. It's different for circles when we get to those. Y equals ax squared plus bx plus c is what we're going to call the standard form for parabolas for this test. So make sure you know the difference between the standard form and the vertex form. The vertex form looks like this. Y equals a times x minus h squared plus k. Or x equals a times y minus k squared plus h. Also, we have a standard form that's x equals y squared, ay squared, plus by plus c. So these two are the standard forms and these two are the vertex forms. So make sure you know which form is which, because on the test you may be asked for the standard form or you may be asked for the vertex form, and you need to know the difference. All right, so on this one it says we want to write this equation in standard form. So we want one that opens left or right, and the vertex is at 2, 4 and passes through the point -1, 3. Well, if it opens left or right, we know that that equation is going to be an x equals. So we're going to write an equation that is x equals ay squared plus by plus c. This is what we want to have in the end. But to get there, we're going to have to use the vertex form. So we're going to use the vertex form to help us out. So we have x equals a. We don't know what a is yet, but we know it with the vertex form we can use the vertex. So we're going to do a y minus k, which is 4, squared, plus h, which is 2. And then we're going to finish solving for a by using this other point, -1, 3. All right, so I'm going to plug in the -1 in for x, and I'm going to plug in the 3 for y, and then I'm going to finish solving for a. So I'm going to subtract the 2 from both sides, and I end up with -3 equals a times the -1 squared is just 1, so it's just a. So I know that a is 3. So now I can write my equation in vertex form. Since I know a is -3, I can write x is equal to -3 times y minus 4 squared plus 2. And now I need to convert that to standard form. Well, to convert it to standard form, we're just going to FOIL this part and add 2 to the end when we're done. All right, so I went ahead and worked that out for you. So we FOIL this together and we get y squared minus 8y plus 16. I still have my plus 2 here on the end, but I'm not going to add that yet until I distribute this -3. So -3y squared, this times this is, oops, that's going to be a plus. Let's change that. Plus 24y minus 48 plus 2. So here we have a plus 24y. Minus 46 is our final answer. Watch out for those negatives. One just got me. All right, in the next section, we are using the information provided to write the vertex form equation for each parabola. So we're gonna actually do problem number 8 in vertex form. Okay, so the vertex form of my parabola is going to be in this form: x equals a times y minus k squared plus h. And the reason why it's x equals is because my directrix is x equals. So if my directrix is located where x equals a -31/4, that means that I have a vertical line going through x equals a -31/4. This also tells me that my parabola is going to be opening right or left. Now, if it's positive or negative depends on whether this directrix is bigger than or less than this -8. Now, since my directrix is less than -8, I'm going to be having a parabola that opens to the left. Now, if you're confused as to whether the directrix is larger or smaller than my vertex, look at the x value for your vertex. The x value is -8. If I rewrite that as a fraction with a denominator of 4, then my fraction is going to be -32/4. My directrix is -31/4, and that is bigger than -32/4. So if your directrix is bigger than your vertex value, then A is negative. And so you need to remember that. You need to keep in mind what direction we're going. So if I have a parabola and my value for my vertex is at negative 8, 4, that puts it about right here, negative 8, 4, and my directrix is at negative 31 over 4, then that means that my directrix is on the right side of my vertex. And if my directrix is on the right side of my vertex, then my parabola has to be opening negative in the negative direction. Okay, so that means that my A value is going to be negative. So what I need to determine is, well, how many units away is my directrix from my vertex? Well, you can find that out by adding and subtracting these numerator values. So if I take a negative 32 and I add 31 to it, I get a negative 1. So negative 1 over 4 is going to be the distance that my directrix is, or 1/4 is the distance that my directrix is away from my vertex. So 1/4 basically. So my p-value is 1/4. And it's negative because our parabola is opening in the negative direction. All right, so how do we find A? Because that's really all we need. The only other thing we need to write our equation is we need the value of A. Well, we know that A equals 1 over 4 times P. We know that. So 1 over 4 times a negative 1 over 4. Well, we've done this before, haven't we? Okay, so 1 over 4 times a negative 4 over 1, that equals a negative 1. So my A value is going to be a negative 1. So now I'm ready to write my equation. X equals a negative, parentheses, y minus 4, close parentheses, squared, don't forget your squared, plus h, which is actually a minus 8. And that's it. That would be our equation in vertex form. The next problem we're going to do is problem 10. Identify the center and radius of each, then sketch the graph. So we're giving a general form of a circle, and we need to find the standard form of the circle, and we're going to graph it. All right, so I've stopped this I've started this process by combining my x terms from my standard form equation. So x squared plus 6x, I put those together, and I'm going to complete the square here to get my value I need for my circle. And then y squared minus 6y, and complete the square here to get the other value that I need for the y value I need for my circle. I moved my 14 to the other side of the equal sign. So I moved it over and I made negative 14. And then when I complete these squares, I'm going to add these values to this side also of my equation. And this is going to be my r squared when I'm finished. So I'm going to have an x squared term plus a y squared term equals r squared. And the values for h and k are going to be also going to be inside these perfect squares, and that'll tell me where the center of my circle is. Okay, so half of 6 is 3. So that's what I have to do to complete the square. Cut 6 in half and square it. So I cut 6 in half, I got 3. 3 squared is 9, so 9 is what goes in this blank. And then over here, this completing the square on this side, I have negative 6. Half of negative 6 is negative 3. So that's what will go here. Negative 3 squared is another 9. So I'm adding 2 9s to my negative 14. So negative 14 plus 9 gives me a positive 4. So my radius for my circle is going to be 2 because this is actually r squared. So I have my x squared plus y squared equals r squared. So I have my equation for my circle. This is standard form circle equation. All right, the h value is -3, and the y value is +3. So at -3, +3, I have my center. So -3, +3, center is right here. My radius is 2 because the square root of 4 is 2. So I go up 2, to the side 2, down 2, and to the left 2. And I do my best to freehand this beautiful circle right here. And that's it. That's your equation. Okay, next we're going to do another standard form equation of a circle. This time we're given the center and a point on the circle, and we have to find the equation from that. So we know the center, so we can write part of our circle. So we know that the x value is going to be +9 squared plus, and then the y value is going to be +11, quantity squared. But what we need is our r squared. We don't know what that is. So we're going to use these 2 points to help us find it. So we're actually going to use the distance formula to help us find r squared. So the distance formula is subtract the x's, so -9 minus a -8 is +8 squared plus, and then a -11 minus a -16 would be -11 plus 16 squared, and then we take the square root of that. Pythagorean theorem. Okay, so here we have 1 squared is 1 plus, and over here we have a -11 plus 16 is 5. 5 squared is 25. So we end up with an r value of square root 26. Well, that means that r must be 26, or r squared is 26, because the square of square root 26 is 26. So my equation then is going to be x plus 9 squared plus y plus 11 squared equals 26. And that's it. In the next section, we're going to work with rational functions and graphs. And so we are actually going to do both problems 16 and 17. And what we have to do for this section is identify the holes, vertical asymptotes, x-intercepts, y-intercepts, horizontal asymptote, and domain of each. Then sketch the graph. So I'm going to focus on those critical values that we need for each one of these graphs. So you could be asked any combination of questions from these graphs, and this is why I'm covering both of them thoroughly on this review. All right, so anytime we're working with rational functions, the very first thing you want to do is factor the numerator and denominator. That is where we're going to find a lot of the information we need for our, not only for our graph, but to answer the questions that we need to answer. So the first thing I'm going to do is identify the hole. Okay, so we know that the hole is going to be located wherever we have a numerator and denominator the same that reduce out. So what we have is an x minus 3 over x minus 3, which reduces. That means that I have a hole in my graph at x equals 3. But what I also need to know is the y value for that hole. So to find the y value, I plug the 3 in I found at the hole into the rest of the equation that I have not reduced yet. So x over x plus 4. So I would plug that 3 in, 3 over 3 plus 4. So that gives me 3 over 7. So my y value is going to be 3 over 7 for my hole. So at 3, 3 over 7, I have a hole. So 3 over 7, it's probably like right around in here somewhere. Okay, now, and the next thing I'm going to do is find some of these other points that we need, like the vertical asymptote, etc. right, so we found a vertical asymptote at x equals -4, and I got that from my denominator. So if I set this equal to 0 and solve for x, I get x equals -4. That gives me this vertical asymptote right here at x equals -4. My horizontal asymptote is y equals 1, and I get that from doing my Bobo Botten eats DC trick. So since these are the same, then I have eats DC. Exponents are the same, divide coefficients. Well, the coefficients are 1 over 1, so my y asymptote is at y equals 1. My horizontal asymptote is at y equals 1. So here it is, y equals 1. So my whole right here is at 3/7. And then I also have an x-intercept of 0. And the way I get that is I set y equal to 0 and solve for x. And the only x I have left in my numerator after I reduce from my whole is this x. So if I make y equals 0, then x equals 0. So 0, 0 is my x-intercept. Well, lo and behold, if that's my x-intercept, it's also my y-intercept. If I make x 0 and solve for y, I still get 0, 0. Okay, so we have an x and a y-intercept are both the same right here at 0, 0. So here comes my graph. I jump over the hole, come through the intercept, and come back down. And then, of course, I have a reflection on the other side of my asymptotes to represent the other half of the graph. And that's it. Those are all the parts that we needed to find. The only thing I did not write was the domain. So the domain value is going to be from -infinity to 4, or -4, sorry, union -4 to infinity. And that's it. So that's how you would write the domain for this graph. Okay, now we're going to take a look at number 17. All right, in this rational function, again, we're going to have a hole in the graph because the x plus 4 over x plus 4 cancels out. So you have to know how to factor these. If you don't know how to factor, then you're going to have an issue. All right, so the top one factors out to be, I factored out the -4, and I had -4, and then in parentheses, x plus 4 in the numerator. And then in the denominator, we have the difference of squares. So x minus 4, x plus 4. The next thing I did was reduce out the x plus 4. That's where my hole is located. So I have a hole located where x equals -4. And now I plug that -4 in to the rest of my equation that's left over, this part right here. And when I plug in a -4 there, I get -4 over -8, which is just 1/2. So I have a hole at -4, 1/2. All right, the next thing I'm going to look for is my vertical asymptote. And of course, that's going to be located wherever this happens right here. We have x minus 4. So at x plus 4, I have a vertical asymptote. So I'm going to write it down, x equals 4. And I'm going to draw the vertical asymptote. Next, I'm going to look for the horizontal asymptote. Well, I'm going to look right here for my horizontal asymptote. I need to look at these values right here. So I have a smaller value on top than I have on the bottom as far as the powers of x. So bigger on the bottom means that I have y equals 0 as my horizontal asymptote. So I'm using my Bobo Botten. Bobo, bigger on the bottom, O, or 0. So horizontal asymptote, y equals 0. So that's going to be right here. Y equals 0. Okay, now, so the next thing we need is the x and y intercepts. So to find the x-intercept, I make y 0 and solve for x. The problem with this is I don't have any x values left up here in the numerator. They were canceled out. So in this case, I have no x-intercept. The y-intercept, I'm going to make x0 and solve for y. Well, when I make x0, if I make x0 right here, this just becomes 0. And I end up with a negative 16 over negative 16, which is just 1. So my y-intercept is at 0, 1. So 0, 1 is my y-intercept. Now I'm ready to draw my graph. It's going to come along the asymptote. It's going to jump over. And it's going to go up the other side of up the side of the asymptote on the other side, the vertical asymptote. And then my other part is going to be down here on this side. And that's it. And now we just need to write the domain. So from negative infinity to 4, union 4 to infinity. And that's it. All right, the next example is problem 20, and we have to write a rational function with the given characteristics. A hole at x equals negative 3 over 2, vertical asymptote at x equals 1, and a horizontal asymptote at y equals 0. All right, so these are our clues. So if we have a hole at x equals negative 3 over 2, that means I have some factor that gives me x equals negative 3 over 2 when I solve for x. So what I'm going to do is I'm going to take this x equals a negative 3 over 2, and I'm going to solve in reverse. So I multiply both sides by 2, and I get 2x equals negative 3. Then I add 3 to both sides, and I get 2x plus 3 equals 0. Or, in other words, I get my factor. And so that's what I need for my numerator and denominator to represent the whole in my graph. So I'm going to have a 2x plus 3 in the numerator and a 2x plus 3 in the denominator. That's what's going to make the whole. Then I have a vertical asymptote at x equals 1. Well, I know that the vertical asymptote comes from the other value that's in my denominator. And this other value is going to be x minus 1. Because when I solve for x, that's how I get x equals 1. So if I solve for x right here, I get x. If I solve for x right here, I get x equals 1. So this represents my vertical asymptote. Then the last thing is a horizontal asymptote at y equals 0. Well, if I use my Bobo Botany Eats DC trick, then bigger on the bottom means that my y equals 0. Well, this is already bigger on the bottom, because if I multiply these two together, I get x squared. So I have an x in the numerator and an x squared in the denominator. So this requirement of y equals 0 has already been met. So we don't need to do anything else to this equation. So our final equation is y equals, or f of x equals this. And we're done. All right, I'm going to also do problem 21, but I'm going to change it. Instead of saying no vertical asymptotes, I'm going to say that we have a vertical asymptote at x equals 0. So vertical asymptote at x equals 0. All right, so let's go ahead and solve this one. We have a rational function given the characteristics a 0 at 6. That means that I have a value in my numerator of x minus 6. Because that's what's going to give me a 0 at 6. A whole at x equals negative 3. So x plus 3 in the numerator and x plus 3 in the denominator. That's what's giving me that whole at x equals negative 3. And a horizontal asymptote at y equals negative 6. Okay, so negative 6. All right, so now the only other thing we need is this vertical asymptote at x equals 0. Well, if I have a vertical asymptote at x equals 0, I must have another x in my denominator. So let's just double check everything. We have a 0 at x at 6. We have a hole at x equals -3. We have a horizontal asymptote at y equals -6. This will give us our horizontal asymptote at x equals -6. At y equals -6. And we have our vertical asymptote at x equals 0. And that's it. That would be our equation. All right, the last problem for this video is find the missing endpoint using the given information. The endpoint is 6, 8, and the midpoint is -1, -4. So I'm just going to write this out and then walk you through what I did. All right, so I used my midpoint formula to find the answer to this one. And I took my value for my endpoint, 6. I don't know the value for my other endpoint. That's going to be this x right here. Divided by 2, that gives me my center, which is -1. And then I do the same thing for the y value. 8 plus y divided by 2 equals the center, which is -4. And then I just solve for x. So multiply by 2, I get 6 plus x equals -2. Subtract 6, x equals -8. Over here, I just multiply by 2. So 8 plus y equals -8. Y equals -16. And this would be the other endpoint. And that is it. Good luck on your test. I hope that you found this video helpful, especially since I'm not going to be in class with you on Wednesday to do the review. It's very important that you watch this video and follow through and make sure that you do all of the problems on your review before the test on Thursday. If you need help, I will be available before and after school each day, including Wednesday, if you need to come to tutorials for practice or help. So please make sure that you get the help you need before you come into the test. Good luck, Longhorns.